Assalamualaikum and very good day. Mina Farzana Fasihah binti SAAID with my teammates IHSAN and ZAFIRA ATIQA. So this is our video presentation for lab 6 entitled Z transform. So there are 3 parts in this lab. For the first one is we need to do some calculation and simulation to convert the systems given into Z plane manually. So this is the question. There are 2 questions here. So from the HN, students need to do some calculation to come out with the final answer in HZ. So after we do some calculation here, simplify from the original question, we need to multiply with Z in order to eliminate the inverse Z. So this is the final answer. Same goes to part B, part 1B. Okay, the same step with part 1A. Okay, so after we got the answer from calculation, we need to compare it with the answer by simulation using MATLAB. So this is the code student using MATLAB. Okay, so for part 1A, okay, so just close all the files open, and then sims is the function to create a scalar value. Okay, so hn is equals to question given here. Okay, so just put all the values here. Okay, and then for z transform is the function that will produce the transform of the z value, and then we will display the answer or the value in the command window by display and pretty function. Okay, so after we click the run button, okay, the answer will preview in command window here. Okay, so we just need to check the final answer of HZ here same or not with the calculation just now. Okay, so this is the final answer for calculation. Okay, just same. Okay, there are not any difference between them. Okay, same goes to part 1B. Okay, this is the command window. Okay, for part 1B. So for HN, we enter the question given in lab sheet here, and Z transform, display the HZ and pretty Z transform. So we will get the final answer here and then compare with the calculation. Z over 1, Z minus 0.5 minus 0.5 over 4, Z minus 0.5. So based on the calculation and simulation, there are no difference between these two methods. Okay, that's all from me for part 1. Thank you.
From part 2, there are 2 additional questions that must be solved. Then we need to find the impulse response of the 2A and 2B manually using the Z transform pair table, and then compare it to the MATLAB output. Then the impulse response of HN can be generated by MATLAB, which can be compared to our calculation result. From the calculation part, first, we need to express the Z transform given by applying the partial fractional expansions, and then each of them from partial fraction can be inverse transform by inspection method, and then the impulse response of Hn can be obtained. While for part B, first we need to express the Z transform givens, and then we need to multiply it with the Z4 over Z4 to get the simplify of the equation here, and then we apply the partial fractional expansions, and then each term from the partial fractions can be inverse transformed by the inspections method here, so that we can find the value of A1, A2, and A3. We said that the impulse response of Hn can be obtained here. The MATLAB part, the inverse Z transform of a signal is calculated using the MATLAB functions of IZ transform H system. And then the inverse Z transform for an IIR system may be determined using MATLAB by declare the system Z variable, declare the system functions, and perform the inverse Z transform on the Z-plane system of H. Besides, the Z transform and the impulse rate graph were displayed in the MATLAB results. As we know, the system is always assumed to be causal in MATLAB. As a result, each approach yields the same outcome, but they are slightly different from the HN for causal system that obtained from MATLAB.
Hello, my name is Muhammad Ihsan. I am to explain part 3. Based on the given LTI system, this is a given equations. For A, plot the poles and zero of the system. First and foremost, we'll see the calculations. Take the equation given and then derive, change the number into z, z-1, z-2, and then z is x -1. So we simplify the equation until we get this one. The equation. So to get the in front z the power of 2, we multiply by this one, and then the final answer is yz equals z the power of 2 plus z 2z 0 equals 0 -2 exact 1 -0.7 z plus 0.125 wholes 0.5 0.25. So we see the MATLAB. For the MATLAB, take the equation from the calculations by this one. So 1, 2, a 1 -3 over 4, 1 over 8. Figure 1. This is for impulse response B, comma A, and then we can run the coding. So we can get the answer like this, impulse response. Then for the number 2, determine the system impulse response if it is causal. So for number 2, the equations like this, and then SYS transfer function BA1, and to find the poles and zero, this is the code. So we can run the coding. So the answer is like this: poles and zero map. Thank you for me.